This is our new high vacuum equipment, which just came in yesterday. Ed Nakaji will have the system running in a few weeks.
Frank, would you tell us about some of the things you've been working on, please?
I'd be glad to. First, let's talk about the wire linearity tester. This is the breadboard model, and this is the production unit recently completed by Ken Miller. Ken, would you mind explaining how this equipment functions?
The purpose of this machine is to select very linear wire for our precision potentiometers. We are training a man from the production coil room to run this tester.
We have improved the main drive in accuracy and in strength so as to give a very smooth feed to the mandrel as it passes through the winding head. The smoothing out of the mandrel feed enables us to obtain very high accurate windings. Recent winding head redesign enables us to accurately control the resistance wire tension while the machine is operating at full speed. Servo control of the mandrel tension further improves the accuracy of the finished coil. A new push-type helixer has been developed to eliminate coil damage caused by old-style helixing.
Well, how are the composite tests of the completed machine turning out, Tony?
Everything looks fine, Frank. We should start production design cleanup in about 2 weeks.
Here is Bob Jenks making a linearity run at 125 degrees centigrade. This portable oven was constructed so that the pot could be mounted on the tester and checked while at the elevated temperature. Similar setups were used for checking all electrical and mechanical characteristics, both initially and after prolonged heat exposure. We are currently working to extend the maximum temperature still higher. Our goal is 250 degrees C and up. Here, Bob Freeman is removing some aluminum parts from the oven. These are being tested for suitability in Helipot high-temperature construction.
As part of our program to solve potentiometer noise, Norm Sneed has developed a special microscope technique to cause semi-transparent noise particles to become visible. Norm is shown here using the dark field technique. Dirty pots are cleaned in an ultrasonic cleaner with suitable solvent or detergent solution, as you see Ivan Atkins doing here.
Here is a typical pot before ultrasonic cleaning. With the removal of the particles, the pot wiper can now make positive contact with the coil so that low noise results and slider opens are eliminated. Here are before and after views shown simultaneously so that you can better note the improvement. Some wire drawing films and other particles are on the resistance wire as received from the wire manufacturer. Some of these films adhere to the resistance wire too tightly to allow removal by ultrasonic cleaning.
These particles and films are removed by a process being developed by Norm Sneed. Norm, would you describe this, please?
Yes, Jack. This process includes the degreasing of the wire, rinse, electropolishing, plated, and re-rinse and re-spooled.
Beautifully cleaned and plated resistance wire is thus produced.
Here to summarize our noise program is Will McCann.
The cleaning of resistance wires and coils is not the complete answer to a low-noise potentiometer. Our research has indicated that further processes and operations are necessary. One of these operations is the coating of a plastic housing such as this with a polyvinyl enamel. Our future aims are for the procurement of a better plastic which will meet all potentiometer requirements, plus having the additional strength material such as this. Finally, the pot must be assembled in an enclosed, dust-free work area. Thus, with resistance wire plating, ultrasonic cleaning, the coating of plastic housings, and assembly in a dust-free work area, the ultimate in noise-free potentiometers may be achieved.